But we are going to learn about stacks in C++. A stack is a data structure that follows the rule, which is this one, LIFO, the rule called LIFO, like that, which means last in, first out. You can think of a stack like a stack of plates. The last plate you place on the top is the first one you remove. Okay, so stacks are part of the standard template library, so we include the stack header. Okay, so we can include it like this. Hashtag, we use the preprocessor directive, hashtag include want the stack, like that. Okay, so from there inside our main function we can return for now. Okay, like that. Okay, so let us take a look at what is a stack. So a stack stores elements in a specific order. You can only add or remove elements from the top of the stack. You cannot access elements in the middle or by index. Okay, so let us now take a look at how we can create a stack. So let's create a stack of integer for now. Okay, so let's delete this one. Okay, so let's create a stack. So to create a stack, we use the stack keyword, and then we are going to create a stack of integers. Okay, so from there we can say numbers, like that, numbers, like that. Then from there we can now return for now. Okay, so here stack int means a stack that stores integers, and numbers is currently empty. Okay, so from there let us now take a look at how we can push elements. So we add the elements to a stack using the push function. Okay, so from there let us go down here. We can say numbers dot push, like that, dot push. Okay, so let us push at 10, like that. Okay, so let us copy this line, copy, and then paste. Let us paste it 2 times, and let us change from 10 to 20, and from 10 to 30, and so like that. Okay, so from there here 10 goes in first, 20 goes on top of 10, and 30 goes on top of 20, and the top of the stack is now 30. Okay, so I think you get it. So let us now take a look at how we can access the top element. Okay, so to see the top element of the stack, we use top function. Okay, so we can get it like this. So we use cout, okay, to get the return the value that the top function is going to return. So the numbers dot top, like that. Okay, the top, like that, and then semicolon. We try to save, and then we try to compile. Let's see the element at the top of the stack. Okay, so as you can see, 30 is now at the top. Okay, so you remember this one that I showed you, LIFO, last in first out. LIFO, last in first out. So the last element is now on top. Okay, so I think you get it. So top function returns the last inserted element, and output here we get 30. Okay, so let us now take a look at how we can remove elements. So to remove the top element, we use the pop, okay, function. So we can use it like this. We can come down here, and then we use numbers dot pop. Okay, so this pop function is going to remove the element at the top, and if we try to output the element at the top, you are going to see that we no longer have 30, we now have 20. Okay, so if we try to save, we try to compile, we try to run, as you can see 20 has become the new top. Okay, so let us now check try to take a look at how we can check stack size and empty. Okay, so let us try to take a look at the stack size and the empty. So here we are going to, let me try to remove these lines. Okay, these lines. So what are we going to do? Let us try to output. So if we want to get the size, okay, the size, we use the size function. Okay, and the size function returns the number of elements. Okay, so we can use numbers dot size. Okay, like that. Then from there we can also, let us check if it is empty. Okay, so we use the empty function which returns true if the stack has no elements. Okay, so let us output numbers dot empty. Is it empty? So it's like checking if numbers is empty. Okay, so if we try to save, we try to compile, and then we try to run. As you can see, we get 3 and 0. Okay, not 30. Okay, so let us try to break this line using the end L. We try to save, and then we go down in our terminal, we try to compile, and then we try to run. As you can see, we have 3 and 0. Okay, so we have 3 elements on the stack, and 0 means false. Okay, so which means our stack is not empty. Okay, as you can see. Okay, so let us now take a look at how we can loop through a stack. So stacks do not support direct looping, but we can remove elements one by one. Okay, so for instance, let us remove these 2 lines, and we use a while loop. Okay, and we are going to check inside here. We are going to check if not numbers if numbers dot is not empty. What are we going to do? If it is not empty, what are we going to do? So down here, we are going to output numbers dot top. We get the one at the top. After getting the one at the top, we can put a comma. Okay, we can put a comma, and then we can try to pop that one at the top. Okay, so numbers dot pop using the pop function. Okay, so here we are trying to output the number at the top. Okay, after getting the number at the top, then we remove that number from the stack, and then the loop continues until numbers is empty. Okay, so from there we try to save, we try to compile, we try to run. As you can see, we get 30, 20, and 10, like that. So the loop runs until the stack is empty, and each iteration prints and removes the top element, and output order follows the LIFO. Okay, the LIFO, yeah, you get it, last in first out. Okay, so when should we use stacks? Okay, so stacks are commonly used for undo and redo operations, function calls, expression evaluation, and reversing data. Okay, so in summary, a stack is a LIFO data structure in C++. Last in, first out, don't forget that. And here we have learned how to push elements, access the top, remove elements, and check size. Okay, so stacks are simple but very powerful. If you enjoyed this part, like, subscribe, and I will see you in the next part. Thank you so much.